Okay, hi, Assalamualaikum. My name is Adam Harid bin Muhammad Nur Azian. I'm from Group 5. So now our group will present about project Multivariable Calculus. Okay, hi. So this slide show our group member. So the first one is Yuva. Yuva Durkeraj, anak lelaki Parameswaran. Their matrix number is CE250111. So their part is report. The next one is Muhammad Aiman Fidaus bin Muhammad Shukri. Their matrix number is CE250084. Their part is MATLAB. Next one is Yi Ziong Han. Number matrix is AE250131. Their part is manual calculation. And the last one is me. My name is Adam Mahrid bin Muhammad Nur Azian. Matrix number is CE250118. My part is slide. So next. Okay. So for the next slide is multiple integral. Okay. So multiple integral are an extension of single variable integration and are used to evaluate quantities over two-dimensional and three-dimensional regions. They are widely applied in engineering, physics and mathematics to calculate area, volume, mass and other physical quantities. Okay, so in this project, we solve the given problem manually and verify the result using MATLAB. Okay, so this slide is about objective. So the main objective of this project are firstly to solve the given multiple integral problem manually using appropriate mathematical technique. Second, to verify the accuracy of the manual solution using MATLAB. And the last one, to compare the result obtained from both method and evaluate the effectiveness of the mathematical software in solving multiple integral problems. Okay, so to complete this project, we follow a systematic methodology. First, we analyze the given problem and identify the integration region and limits. Next, we solve the problem manually by apply the appropriate integration technique step by step. After obtaining the manual solution, we use MATLAB to perform the same calculation and verify the result. And finally, we compare both result and draw conclusion based on the findings. Okay, for this project, we select MATLAB as our mathematical tool to verify the manual solution. MATLAB was chosen because it provides accurate symbolic and can solve multiple integral problem efficiently. It also helps reduce human errors during calculation and allow us to verify the correctness of our manual solution. In addition, MATLAB is widely used in engineering and scientific application due to reliability and powerful computational capabilities.
So this is the problem that we need to solve in our assignment. As we know, the question given x is 1 to 2 and y is -1 to 1, and we just do the simple integration for ds, and we will get the answer. Then use the same answer to do the integration for dy, and then we will find the final answer is -28. And then for part B, the step is similar like part A, and we know the y is 0 to x squared and x is 0 to 1 over 3, and then we do the integration for dy, and then do the integration for ds, and we will get the final answer is 17 over 4,860. For question 2, the r can be found by using the two equations from the question, and it will be 1 to 2. And for the theta, since the question mentioned upper half, So it will be 0 to pi. And then we just do the integration separately. Firstly, we do the integration for d out, and then we do the integration for d theta, and then we multiply it, and the final answer is 62 over 15. So for the question 3, firstly, we need to find the differential for x squared and y squared, and then we get 2x and 2y, and then we start into the surface area formula, and we get the answer is 1 par 4x squared par 4y squared, and we know x squared par y squared is equal to r squared. So later we will use the 1 plus 4r squared in our integration, and then now we need to find the r and theta. For the r, we can find it by using the equation given from the question. E is 0 to 1, and for the theta, since it is the full parabola, so it will be 0 to 2 pi. Then we need to do the integration separately for dl and d theta. For the d theta, we just do the simple integration, and for the dl, we use the substitution method to do the integration. And since dl changed to du, so the integral also changed from 0 to 1, change to 1 to 5, and get the answer. And then we multiply it and get the final answer is pi over 6 multiplied by 5 sub 5 minus 1.
Hello everyone, my name is Yuva Dimkiraj Analaki Parmeswaran, and my metric number is CE250111. Well, today I'm going to explain about question 1A. From here we can know that how MATLAB is work with a question that we give, and it shows solutions for it and the graph and more on. So we can know that the MATLAB is trying to demonstrate us on how to solve and visualize a representation of a double integrations problem for the question 1A over a specific region R. So for your information, I just want to inform that the question 1A is a double integrations problem. So move on for the question 1A. So we utilize MATLAB is mathematically solve and visually analyze our function over the defined region R. So the code on the left side, you can see from the script. Firstly, we define our symbolic variables x and y, and our input integrations function, which is f, x and y. So okay, we can see that the question is 2xy to the power of 2 and minus 4x to the power of 3. We then execute a step-by-step double integrations by using the int, which are in the coding command. So the inner integral evaluates to 3y to the power of 2 minus 15y. So, and after computing the outlet integral from negative 1 to 1. And okay, we get to know that MATLAB yields our final analytical answer of negative 20. So from the visualizations, to better understand the behavior of the functions, we can know that we generate the 3D surface plot using the FSURF commands shows on the right side. So we get to know that the plot visualizations of f, x, y exactly over our bonds where 1 smaller than our x and smaller than 2, and negative 1 smaller than our y and smaller than our 1. So from here we can know that the color gradients beautiful maps out of the changing value along the z-axis. Dropping down, it's to the lowest point near to the negative 30 degrees. Moving on, I'm going to go for the slide 2, and I'm going to explain about the solutions for the question 1, which is regarding the coding and the video interference. So let's go to the slide 2. Hello everyone, welcome back. So from here we can show that the live workspace and the executions environment to prove that the calculations work seamlessly in a real time. So for the transitions, we get to know that the slides give us closer look on how our MATLAB active workspace environment during the execution. So I will play this quick clip video showing how the script running live well. So for the next slide, you guys can see that the videos and how the graph works and everything. So notice that the variable stored in our workspace on the bottom left. So it confirms that our symbolic outputs match on our manual derivations expectations. So can say that the comments window output at the bottom shows it's clean. Final termination verifications and an inner integral of 3 to the power of 2 minus 15 and the definitive final answer of negative 28. Why this matters? It's because of the leveraging MATLAB symbolic math toolbox. So we can ensure that our manual integration steps are not just theoretical sound, but computationally it's perfect. So moving on to the manual calculations. Hello everyone. In this live demonstration, which is on the third slide, you can see our script for the questions 1A being executed in the MATLAB as it runs, and keep an eye on the workspace on the left side where our symbolic variables are registered and the comment window of the bottom. So the code automatically prints out of the intermediate step by step to the inner integer, so which it yields 3 power of 2 minus 15 before computing the outer integral that gives us our final verified answer of negative 28. So finally, from this video in this slide, it shows that the script is seamlessly generates in the 3D surface of the plot by utilizing the fsurf command along with the precise exit label. The software gives us an instant interactive and look at the geometrically of the function across our exact integration boundary. So this is only from my side, and thank you so much.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus bin Shukri. My matrix number CE250084. So my first part, which is software solution Q1B. So you can see the final answer, which is we get 17 divided by 4860. So the manual calculation they are same. So the next, which is you can see the graph we get in 3D graph in question 1B. So my next slide, which is software simulation in Q1B. You can see the simulation and how we get the graph on Q1B. So my next slide, which is software simulation in Q1B. You can see the simulation and how we get the graph on Q1B. So the next slide, which is software solution in question 2. You can see the answer in question 2. Final answer we get 62 divided by 50, which is the same calculation in manual. So the 3D part, you can see the software generate in 3D part, which is 3D graph. So the next slide, which is software simulation. You can see software simulation in Q2, how we get the answer and the graph. So my next slide, which is question 3, software solution. You can see the final answer we get 5 times 5 power of 1 divided by 2, so minus 1 and divided by 6. So the manual and the solution calculation the same, but the different format. So you just expand 5 power of 1 divided by 2 to 5 thirds 5. So this the same format, just change. So next is software simulation, you can see how we get the graph and the answer. So next is software simulation, you can see how we get the graph and the answer. So the next, which is software simulation question 4, you can see the final answer is 8 divided by 50. So the final and the manual solution is the same, and you can see the graph we get in MATLAB. So next is software simulation, you can see how we get the graph and the answer. So next is software simulation, you can see how we get the graph and the answer. So next is software. So my last part, which is conclusion. So the first, the objective of the project were successful. Number 2, which is the multiply integration problem, was solved the manual and verified MATLAB. Third, both method production educated result. And the last, which is MATLAB improve be effective tools to validate mathematical calculation. So that's all from us. Thank you.